When one is injured and receives a minor wound, your body responds with a combination of factors to stop bleeding. The arrest of bleeding from a damaged blood vessel is called hemostasis. The action of hemostasis can be summarized into 3 different factors: vascular, platelet, and plasma factors. At the site of an injury, one of the first steps of hemostasis is vasoconstriction around the damaged blood vessel. This can be performed by the stimulation of the middle layer of the blood vessel, largely made up of smooth muscle, the tunica media. Contraction of the smooth muscle results in an increase in the systemic blood pressure in the localized area. As blood continues to flow through the injured site, exposed collagen at the opening of the damaged vessel will allow passing platelets to adhere to the area. The alpha granules release polypeptides such as fibrinogen, the von Willebrand factor, growth platelets, and protease inhibitors. Dense granules contain more small molecules such as ADP, ATP, serotonin, and calcium. These release proteins and small molecules all play a part in hemostasis. For example, ADP's ability to attract additional platelets, serotonin as a vasoconstrictor, and the von Willebrand factor to bind to factor VIII to assist in platelet adhesion. Within hemostasis is a process known as the coagulation cascade. Ultimately, this process results in the production of thrombin that will convert fibrinogen into fibrin in order to form a blood clot. However, there are several protein and enzymatic factors that are necessary to start and continue this process. When tissue cells are first damaged, factor III, tissue factor, is released. An increase of calcium cations activate factor VII, which will bind to factor III to begin the extrinsic pathway of the coagulation cascade. Plasma protein factor 12 then activates factor 11 and then factor 9, initiating the intrinsic mechanism of the coagulation cascade. The extrinsic and intrinsic mechanisms collide together to activate factor X. With factor X, factor V and then factor II are sequentially activated. With the activation of prothrombin, fibrinogen that normally circulates through blood is converted into fibrin by prothrombin. Fibrin will form a loose mesh around the damaged area, and factor 13 will create a covalent crosslink between each strand of fibrin. With dense fibrin covering the damaged blood vessel, a blood clot has been formed, and hemostasis has been completed.